안녕하세요. AI 연구센터장 권영준입니다. 텍토닉 2020의 첫 번째 키노트 스피치 연사로 특별한 분을 모셨습니다. 하버드 대학교 컴퓨터 사이언스 학과의 빌 게이츠 석좌 교수이신 HT 쿵 교수를 모셔보겠습니다. Hi HT. Good morning.
How are you?
I mean good evening for you rather. First of all, I'd like to thank you for accepting to do a keynote speech for us. How are you?
Good, thank you.
It's been more than a year for me to work for SamsungSDS here in South Korea, thanks to your advices and all the interesting AI research we've done together in the past. I hope Harvard, Boston, Cambridge, and the US are doing all right in this difficult time of the coronavirus pandemic. So with that, now, shall we begin with your keynote?
Yes. Okay. You see my screen, right?
Yes, we do. Please go ahead.
Okay, so thank you, Yoonjun, for your introduction. I'm very pleased to have this opportunity to present a keynote speech on AI and the pandemic. We all know that AI is transformative, so is disruptive technology. Pandemic is of course disruptive. So at this time, it's a very unique in history. These two disruptive forces meet. There must be some interesting implications and lessons we should learn about. So I will discuss this. So my agenda will be as follows. I will discuss some of the limitations AI are being exposed by the COVID-19 virus problem we are having. We are seeing some of the limitations. Then we discuss some of the reasons for these limitations. Some of those reasons are pretty fundamental and at the structural level. So we may want to pay some attention about these reasons. Then we present some kind of goals or visions in addressing those limitations. Finally, I'll make some suggestions on some near-term concrete steps we may do. We know that there are many AI efforts for COVID at this moment ongoing. There are virus classification work, detection and emerging outbreaks and infections individuals. There are contact tracing and tracking programs going on to complement the social distancing. We also have works in figuring out the optimal lockdown strategy. For example, I wonder if we can lock down in a small region, do some kind of micro lockdown rather than in a very large area, which could have a severe impact to economics. Of course, there's a vaccine development, especially using deep learning. The problem in that area has been that AI is probably not the most important thing there because the human subjects in the field test probably takes much more time and effort. COVID-19 has exposed some of the limitations of AI. One, AI solutions we find cannot be developed in real time. In the meantime, virus spread and the mutation will not wait. So AI solutions development need to be sped up. Second limitation is that for new diseases such as COVID-19, we lack of historical data. As a result, some of the training will be difficult. because we don't have labeled data. In that case, we need to figure out ways to deal with this new phenomenon, which in the future we may have again. So that'll be a challenge to everybody, every one of us. The third big issue is that we have a new set of new kind of data emerging very rapidly, resulting from abrupt changes in user behavior, shift to remote work, and increased use of robots. So these are the three limitations. We are not doing that well. So there's some kind of explanation for that. One of the thing we need to work on is we should try to shorten the AI pipeline so that the development time can be sped up. The second one is we probably need more innovative methods in the domain so that we can have a better, more effective AI-assisted solutions. The third one is we really need to work with domain experts more deeply, more easily, such as biology people. These goals have different strategies to deal with it, so I will discuss some of them with three visions. Let me talk about the goal one, shorten AI pipeline. Currently, the AI pipeline is pretty long. It starts with data acquisition, followed by AI model development or training. Finally, we have system deployment. This pipeline is long in following sense. It's long in time. We have a long turnaround time to go through this pipeline. Every time you make a new change, you have to go through this whole pipeline again. So the turnaround time is very long. It could be 6 months, 1 year, or 2 years, or even longer. The other issue is the pipeline actually spans multiple domains, sometimes under separate management. As a result, it's hard to do system level or pipeline level optimization. So what we need to do is to streamline this pipeline, especially on the two ends, this data acquisition and the system deployment. We actually spend most time in these two ends rather than in the middle. However, efforts in AI very often, at least academic effort, very often is spent in the middle. So we need to fix this problem. We need to have more unified pipeline management and organization. So this leads to a vision. One day probably we can do the entire pipeline in a single fully integrated process. So model training is carried out in place on the fly alongside of data acquisition and the model deployment. In this way, AI models can keep pace with new data. Of course, when you want to do in place, on the fly learning, you should do this in a distributed way. You do this in multiple local nodes on the fly. So this is related to federated learning, for example, across different organizations. So organizations can individually train their models and collaborate in the model while not revealing their own data. To do this in place, very often we need to have edge node optimization and accelerations. The second thing is we probably need to spend much more effort in devising innovative domain methods for AI-assisted solutions. If we just trying to speed up or using AI for standard methods, the performance gains usually is marginal, only probably a few % of accuracy improvements. These small gains very often cannot justify the added cost of using AI. So we probably should do is to adopt AI screening so that we can identify and experiment with new aggressive methods, which can lead to substantially higher performance gains. For example, a vision could be ramp up the domain methods for ambitious AI performance goals, develop new generation of domain methods which leverage AI assistance. For example, for manufacturing, for healthcare, we may really trying to work on digital twins so that we can avoid some of the human subjects delays. We can fundamentally speed up the domain effort. The resulting AI-assisted solution could be disruptive now. Third part is about acquiring domain expertise for AI. Domain expertise know-how is very important because only domain experts knows how to extract useful features, especially some of the features are nonlinear, which could be ratios of two control parameters. Only the experts know how to determine what data to include when training. They can synthesize data for real events and corner cases which we never have enough data. So we need the synthetic data. They can check if the model is consistent with physical evidence. However, requiring expert domain knowledge isn't challenging because experts have very different opinions sometimes. The more importantly, human experts are the most expensive resources in this whole effort. The art is really in minimizing such costs. One way to do that is to use a data-driven method. We instead of capture experts' logic directly from input data to decision, we take the input data and decision as input and use the outcome as output. So we learn from those input-output relationships using data-driven method. We can capture the experts' knowledge. So this is some of the efforts looks quite promising. These are some of the examples where you can use expert knowledges, expertise of the experts to build, for example, some useful expert developed tools that can be really used widely by all sorts of applications. Maybe we can have experts develop differential equations to devise and to invent analytical shortcuts without model trainings. For example, optimal control for micro lockdowns. These are mostly control kind of methods. We don't need elaborate machine learning data-driven method, probably. We can use experts to help us to build some physical simulators or simulations, for example, for 3D scenario using the Unity kind of simulators. For chemical engineering, we can use Aspen simulators. They all very useful. They can be used in all sorts of applications. Then the expert times can be saved because their work can be used in many different scenarios. Experts' insights on distributions data will be terribly useful. So the software packages could be used for doing the automatic data acquisitions or model learning. I have finally, I'm going to suggest we can, in the near term, we can do something relatively attainable. For example, to have a mobile healthcare infrastructure. This low-hanging fruit is a must-do. We can have millions of smartphones implementing social networking for distributed in-place on-the-fly data acquisition, learning, and deployment. We can use 5G networks to enable disruptive new approaches while protecting user privacies. In the meantime, we can work out some joint decision workflows so that human, AI, sensors, and other equipment can work together. One of the key things there is probably some very good user interface for the operators to see relevant data and to input the experts' knowledge into the systems. Some kind of operator's cockpit, just like a pilot need to have a very good cockpit in order to do intelligence in the control of the airplane. In this situation will be similar. At the end, we need humans to be able to control all this AI outcome and also equipment and so on. Conclusions. the pandemic really has revealed the importance of some of the effort we need to pay more attention. For example, we really need to speed up the AI solution development process so that they can be done probably not real time, but at least near real time. We need to do this. We need to shorten the AI pipeline, especially at the two ends, data and deployment. We need to work out some joint workflows so that AI results can be used in clinics, in factories, and so on. AI experts know how for domain collaboration is hard in general, but this is essential. As I mentioned, there may be some kind of focused efforts in capturing experts' knowledge in terms of expert tools that will be useful, so that a lot of people can benefit from these tools without costing a lot of times from the AI experts, from the domain experts themselves. Short-term actions could include mobile healthcare infrastructures, and I mentioned that this operator carpet. This operator carpet is kind of really very useful. If you have this thing, you probably can control your factory, control your clinics, control everything so much more efficiently, because data and relevant logs and so on will come to you automatically. So the last point I want to make is that this pandemic has demonstrated urgent need to support all forms of remote operations with AI and the related regulatory reforms. We have a lot of wish. We could, for example, we always wanted to have some kind of remote telemedicine, but the regulations make this very difficult for us to do. Maybe this pandemic will give us enough will so that we can reform the regulations, finally solve some problem we wanted for years. So we will have our hands full in the next several years. Thank you for your attention.
Thank you, HT, for your presentation. Now, let us have a quick open discussion for about 5 minutes or so. To do so, let me ask you my first question. You've mentioned the pandemic and the AI as the two disruptive forces, and of course, your viewpoints toward the ways of doing technical research and possible modifications upon the interplay of the two. What are your current AI research that reflects these? Or how does Harvard, or maybe MIT nearby, also as an elite university, take your points into considerations for academic research?
Yes, this is something I'm very kind of interested in, and I pay attention to it to make sure our research is related to this big picture. I have 2 lines of research which is related to what I discussed today. One is we have this research related to tiny ML, small machine learning for edges, so that we can do this in place, on the fly, distributed learning, and so on. So this stuff will be run on embedded device. So we have also a whole bunch of methods trying to compress models, trying to use dynamically configurable precisions for quantization and so on. The other general area, which is I think is really going to be very, very important in the next several years, is to do distributed learning, such as federated learning I mentioned earlier, so that different organizations, different devices across the globe can collaborate. And one of the efforts in this area actually is about a marketplace even. One day I see that we're going to using building blocks of AI models. So we're going to have thousands or tens of thousands AI model components ready for people to put them together to form large AI models. So we have effort going on, which will be doing a marketplace on blockchain for AI model components. And in terms of collaboration with other universities, we're actually writing a proposal in this area with MIT on methods of putting different tools, models together on a platform so that we can do plug and play. So I guess I'm saying is really we want to do is no longer this single kind of effort. We're trying to do a more collaborative effort. Fundamentally, we want to be able to develop interesting models in a collaborative way over the networks in a distributed manners, and also get them get the edge nodes to learn by themselves in a distributed manner. Okay.
Thank you for your thoughtful answers. My next question to you is that Samsung SDS is an IT software company for the Samsung Group. As a global elite tech company, what do you think that Samsung's roles in this pandemic era should be?
Yeah, it will become much more important than ever. You know, some of the stuff I said, for example, about operates cockpit,
Yep.
operates the control console. This really is IT work. And this IT work probably is the backbone of all the other things. So that you can, with good IT, you can really leverage all the clever stuff people do with AI. You can put those AI predictions, past histories for this particular data sets and all stuff in the operator's window, so they can make decisions. This work fundamentally is IT work. There's another line of work I think will be terribly important in the coming years, is to deal with this new data. You know, the data we are going to have in the next several years will be very different from the past data. This data result from this abrupt changes in user behaviors due to COVID, a shift in remote work, and increased use of robots. All this stuff we need to understand how this new norm, so-called, means, and how we're going to control this situation, how we can live in this environment. I think some good data capturing, learning, and deployment for this new kind of data due to this COVID thing we are facing will be with them for a long time. I think this model change is going to be pretty long term. So we should be ready for that. I think that's, again, it's basically a new software effort. We have to new kind of viewpoints and new architecture and so on.
Got it.
Oh, yeah.
Okay. Thank you for your interesting views on these important matters. Hopefully, the coronavirus pandemic will soon be overcome and the world will move on from here. I'm glad to see you and listen to your keynotes for Techtonic 2020. And once again, we thank you for your participation. I'll see you next time then.
I hope you have a wonderful meeting. Thank you for the invitation. I enjoyed my presence and participation. Thank you. Bye-bye.
Thank you. Goodbye.